Hey students, welcome back. Today we are going to look at accounts merge problem on LeetCode. This is a slightly difficult problem, so follow through carefully. So let's look at the problem statement first. So the problem statement says we are given a list of accounts where each element accounts of I is a listing of strings. The first element accounts I of 0 is a name and the rest of the elements are emails representing the emails of that account. So we are given list of strings and the first element of the list is a name. Rest of them are emails of that person. Now what do we have to do? We would like to merge these accounts. So given many such accounts, we have to see if a merging of them is possible. Two accounts definitely belong to the same person if there is a common email to both the accounts. So the merging criteria is if two different people have the same email ID, then that means the accounts are same. Okay. Note that even if two accounts have the same name, they may belong to different people. So the vice versa is not true. Having same name doesn't mean they're same people, but having same email means they are the same people. So we have to merge all such users who have the same email account. Okay. A person can have any number of accounts initially, but all of the their accounts definitely have the same name. So the thing that is given is name of the person will be same across all these accounts. Okay. So after merging the accounts, return the accounts in the following format. So after merging, we have to return in the same format, which is first element is the name and rest are the emails of that person, which are after the merge, but they should be in sorted order. Accounts themselves can be written in any order. Accounts can be in any order, but emails of the user should be in sorted order. So that is the question. Let's look at an example that will give us maybe slightly better idea. This is a slightly difficult to follow, so read through carefully. So here we are given four users. Okay, one is John, another John, Mary, and another John. So here, if you see in the first two Johns, johnsmith@mail.com is the common email ID, which is why in the output we have to merge these two Johns. So here it would be John, John New York, and John Smith all under one John. Okay, these four merged, duplicates were removed and sorted under this user. Okay, whereas Mary, she doesn't have any other common accounts, so this one stays as is. Similarly, this John also doesn't have any common accounts, so this one also stays as is in the output. Okay, so wherever there is a common name, we have to merge them. Here also it follows the same one. Initially there is Gabe, Kevin, Ethan, Hanzo, Fern. All of them are unique, so they'll stay as is in the output. Okay. So to understand this problem, to solve this problem, we will be using something called disjoint sets. Okay. Uh, union find or disjoint sets. Union find algorithm or disjoint sets. This is the concept we are going to use it. This is the same thing that is used in Kruskal Algo as well. Okay. So we will be using the same concept. Okay. Now let's take an example and see how we can find disjoint sets. Then we'll come to the problem. Since this is slightly complex, let's take it a bit slow. Okay. Let's say we have this kind of a graph. 0, 1, 2, 3, 4, and 5. So we have six nodes forming two disjoint sets. Now, how do we figure out the disjoint sets using union find algorithm? Okay, so all these sets are represented through an array. Okay, so 0, 1, 2, 3, 4, 5. This is the index of the array. So initially, everything is pointing to itself. That means only itself is there in that set. Okay, so if sets of I equal to I, that means that is the root element. Okay, so initially we have five distinct sets, or sorry, six distinct sets: S1, S2, S3, S4, S5, and S6. Okay, these are the sets we have. Now what we will do, we will add each edge to it one by one. Okay, so this is our graph. Let's name the edges. Okay, these are the edges we have. Now let's add each edge one by one to the graph. Let's say we are adding edge A. So A has 0 and 1. Okay, and they are linked to each other. So in this set, 0 is belonging to one set and 1 is belonging to another set. Since there is a edge connecting both of them, now we have to merge them to the same set. Okay, now we have to merge them to the same set. Okay, so these two together forms a set. Now how do we represent this? This is mathematically forming the sets. How do we represent this? So what we will do is, for vertex 1, we will change the parent to 0. Okay, which means both of them are in same set. So we will use 0 as the root element. You can take anything as a root element, but for this example we are just taking 0. Even if you take 1, the output will still be the same. Okay, so after adding A, this is how our sets array will look like. So 0 and 1 are in the same set and rest all are in four disjoint sets, which is mathematically represented like these sets below. Okay, now let's add vertex B, which is 4 and 5. Okay, 4 and 5 are not already here, so we will add it again. Okay, so 4 and 5 are in two different sets. Here is 4, here is 5. So if they are in two different sets and there is a edge joining them, we have to combine the sets. That is what is called union of the union find. Okay, now we will join 4 and 5 to form one set. Okay, so far it's pretty straightforward. Now let's add C. C is a vertex from 1 and 2. So 1, now we have to find the find of the union find. We have to find where 1 is. 1 is in this set. Okay, where is 2? 2 is in this set. So there is a edge connecting 1 and 2. So we have to join these two. Okay, these two sets. So this becomes 0, 1, 2 now. Similarly, in the graph, if you represent, this becomes part of the zeroth set. So here also we will update the index to 0. Okay. Remember, it is not, it is called the collapsible root. So 2 is pointing to 1 and 1 is pointing to 0. So since we are only interested in the sets it represents, we are just updating 0 here. Okay. Now let's look at the last edge, which is edge D. Okay. The edge D has two vertices, 2 and 3. 2 is in this set and 3 is in this set. So similarly, we have to merge these two sets following earlier logic. So this becomes like this. Okay. Similarly, in the sets array, to represent this, we will change this to 0. Okay. We forgot to update the index for vertex 5. This becomes 4. So if you look at the array, there are two distinct sets. One which can be accessible from 0, the other which can be accessible from 4. Okay, these are the two distinct groups that can be formed with the given graph. So we will follow similar logic for our merging the emails problem as well. So let's work it out through an example. Let's say this is the input we have. Okay, Okay, we have 4 nodes. Okay, so let's call each of them 0, 1, 2, 3 respectively. Okay, and here if you see this graphically, what it means is the first email, which is johnsmith@mail.com, let's call it JS for simplicity, it has an edge to 0. Okay, johnnewyork@mail.com has an edge to 0. John Smith has a at mail.com has an edge to 1. Okay, John00 has an edge to 1. Okay, Mary has an edge to 2. John Bravo has an edge to 3. Okay, so if you compare it with the earlier graph, here if you find if you find the disjoint sets, it would be 3 sets. Okay, all all these will form into one set. This one is one set. This one is one set. So we can employ a similar algorithm which we used earlier, the union find algorithm, and figure out the output. So let's again process it edge by edge. Okay. First, let's process John Smith. So initially, let's take an array of size 4. Okay. 0, 1, 2, 3. Okay. Initially, they point to themselves because they are 4 distinct sets initially. Okay, there is no joining between them. Now, let's process the first edge. First edge is johnsmith@mail.com pointing to node 0. Okay, so it is still, there is no interconnection yet. Okay, next one is John Newark pointing to 0. Okay, next one is John Smith pointing to 1. We already have a John Smith existing. Okay, so what we will do is, since this John Smith is pointing to 0, we will update the index of current node, which is 1 to 0. Okay, then there is John 0 pointing to 1, and we have Mary pointing to 2, John Bravo pointing to 3. So all these, there is no change. So with this, we found the disjoint sets by processing the each edge of this graph. So what did we do? At every point, we figured out the probable parent of it, and we updated this index map or the sets. This is the sets array with that. Okay. Now from this sets array, we have to compute the actual email list. Okay. So how do we do that? We have to compute the email map. Yeah. So to compute the actual map, we will accounts map. We will use these two data structures that we have. Okay. We will process edge by edge. These are all the unique edges that we have in the graph, right? These are all the unique edges that we have in the graph. So we will process one by one, and we will update we'll create another map forming list of emails for each user. So the first edge is JS pointing to 0. Okay. Here 0 is a point in the sets array, 0 is still pointing to 0, which means it's a root node. So we can consider this. So 0 has JS. Now there is JN pointing to 0. Again 0 is 0. So it will be JN. Then there is 1 and J0. 1 is pointing to 0. So we will not put this at key 1, but we will update it at key 0 itself. Okay. Now, then we got a index 2. 2 is pointing to itself. So this will be M. Similarly, this will be, okay. So now we have this mapping of each index to the list of elements. Once we have this, we can reframe this to whatever output format that we need. Okay. So observe this carefully. What we did, we created a edges array and also a sets array. Okay. Edges represent all the unique edges in this given graph, and the sets array represents their disjoint sets that are available. From these two, we will compute the output. Okay, let's write code for this. So the code also will be slightly complex. So please follow carefully. Okay, okay. Let's go to the code editor. Let's maximize this. So initially, what we said, we have to take a sets array which has exactly which is exactly the size of the accounts we have, and we will initialize it to itself. Okay, so for that we will just do a integer array sets, and we have to initialize it itself to itself, right? So let's create a int string from 0 to accounts dot size. We are not looking for a string, we are looking for a array. Okay, so this will create a int stream from 0 to accounts dot size minus 1, and it will translate that to array. So instead of initializing an array in a for loop, we can do this in a shorter way. Okay, next, so this one is the sets. This one has the disjoint sets. Okay, now we have to compute the unique edges and update disjoint sets. Okay, this is what we will do now. So what we need is a data structure to hold the edges. So it is email to node mapping. So it is string to integer. Okay, edges. We are taking a simple hashman. Okay, now for each account. Okay, index less than accounts dot size. So we are processing the entire accounts array, and we need to figure out each edge of the graph, right? So we have to take each account, and in each account we have to process each email, which would be an edge. So let's get the current account. Okay, accounts dot get of index. Okay, so we are processing one account at a time. The first element of the account is name. So here we are interested in only edges. We are only interested in emails. So we can start at 1. Okay. So how many ever emails this account has? We will process all such emails. 1 to size of the second list. Okay. So now what is the key element here? Which is email, the current email that we have. Okay. Once we get the key, if our edges, if it already contains key, okay, if it already contains this email, okay, then we don't have to put it again. Otherwise, we simply put this email and the current index. So we are saying this email is pointing to the current account index, which is this index. Okay. But if the edge already exists, that means we have a repeated set and we have to merge it, right? Okay. That means in the sets array, okay, we have to update the index. Okay. We have to update which index. It need not be the current index. Okay, the current index may already be updated to some other value, so we have to go recursively until we find a root index. Okay, we will write a helper method to get the root. Okay, so sets of the current index. So the root of the current index, okay, will be updated to the root of whatever value we have at key. Okay. So what we are doing here is the current edges or the current emails existing node. We are getting that and we are figuring out which root it is pointing to. Okay. Once we get that, we update that value to the this current index is set. But there is a possibility that the current index also got processed once, which is why we have to get to the root of the current index and update that. Okay. For example, if there are two emails in an account which are in two different accounts, okay, that is the case where this is required. Let's say John has email 1 and email 2. Email 1 is in one set, email 2 is in another set. So with email 1, we will already update the current index value. With email 2, we have to update this entire chain to the new value, which is why we have to get the root. So let's first implement the root function to clear some confusion. Okay, yeah. So how do we implement root? Integer array sets. Okay, how did we define root? If sets of index is equal to index, then that is root. Okay, so what we will do is while this is not equal, we will keep going inside it. Okay, index equal to sets of index. Simple. We are just going till we reach the parent of the node. Okay, we will return that. So we will get the parent of the current index, update that in sets to the parent of the current node of the edge. Okay, so this line is the most critical part. So understand it carefully. Okay, so once we have this, we will have a unique edges map and also we have updated the disjoint sets array. Okay, so now we have to create that accounts map. Okay, create accounts map. So for the accounts map again, it is a integer ID pointing to list of emails. Okay, so okay, so we will process each unique edge, which is whatever edges we just computed. Okay, in edges dot entry set. Okay, in the edges we computed, we will process each edge and we will compute the value in the accounts map. So with each edge, first we will get a index. Okay, again we will get the root value of the index. Okay, we got the index. Then for this index, we will update the accounts map. So there is a possibility that this can be the we might be adding it for the first time. So we have to do compute if absent. Okay, accounts map dot compute if absent. Okay, what is our key for this map? It is the index or the vertex value. And if it doesn't exist, we have to create a new array list. Okay, once so what this will do is it will from this map it will get the list at value at index. If it doesn't exist, it will create a new list. You can also say contains key, and if it doesn't contain, then create new, etc. But this will do that in one line. So after this, we will have a array list. To that array list, we just have to add the current entries email. Email is key of it. Okay. Okay. So we have the, so this will give us a map of each index or vertex pointing to the list of values. Now we have to translate this to the output. So output should be list of lists. Okay. Output should be list of lists. We have a map of lists. We have to form the required output. Okay. Yeah. So now for let me just copy this in the accounts map, not edges. So for each entry in the accounts map, okay, first the key of it is the user or the vertex, right? So we have to get the user value first. Okay, user value is nothing but entry dot get key. That is the index. Okay, accounts dot get, accounts is the given accounts array. Entry dot get key will give us the entire list of it. The username is only the first value of it. So far we haven't processed the user value anywhere. So if we just get the first value at this index or the at this vertex, we will get the user associated with it. Okay. And the way we form the list, it is a list from index to list of emails. So the emails is nothing but entry dot get value. Okay. So we have user, we have emails. There is another thing that emails should be sorted. So we will sort the emails using collections.sort. Okay. So how is the format of our list? It should be username followed by emails. Okay. We have user and emails. So in the emails list, at the first, let's add user. Okay. So now we have the required list. So in the merged accounts, we formatted the required list. So we will add that to merged accounts. Okay. So we formatted the output in the required format. So we will just return that. Let's submit this and see. Okay. There is a compiler error. Let's see. Okay. Okay. Here we missed a brace. Adjust dot get key should have a, we have to get the key at the current value and then pass that to the get root method. Okay. Entry set. Okay. This one is list of integer and list of string. Okay. Yeah. So let's submit this and see. Okay, it got accepted. So the reason why we did get root here and here, it will be clear through different examples. So take a look at this example, for instance, where a node is merged to its previous and so on. So if you walk through the code or do a dry run with this example, it will be much clearer for you. I highly recommend write the code and do a dry run with this example. Okay. Yeah, that's all for now. Thanks for watching. Happy coding.